Good morning to all. In this video we are going to do the simulation on the gate netlist, that is we saw in part 1 and part 2. In part 1 we saw using the Virtuoso and part 2 for the VCS. Now we are going for the NC launch from the Cadence. So all are the details are given in part 1 and part 2 regarding the how we generate the gate netlist. Still for the wrap up, I just overview all the details in short. So we create a RTL to netlist by using the design vision or RC compiler. These are the details. We need the source file constraints and the library, and the outcome of this process is gate netlist and other reports like power, area, timing. And we took a small circuit as a source file, FSM test1, in which clock reset our inputs, RGY is the output, and it is a small final state which gradually logical 1 or logical 0 repetitively on the RGY as shown in the waveform. For the sake of reference, I just put the code for this FSM, and this is the XDC file for the reference, and we are using the 45 nanometers. These are the files that we are take as a library for the 45 nano. In this .v file is important for us for the gate level simulation. And if you saw that file .v file, it is a combination of the cells, that like cells means AND gate, then inverter buffer like this, or DFF with specified timing constraints. And after conversion from the design vision, we found that 93 cells are required for transferring that FSM code into the gate netlist. For RC compiler, there is a 17 cells are required presentation. For the simulation of gate level, we need gate level file. From the RC, it is RC. If it is S45, it is from the design vision. This on this NC launch, one test bench and the reference technology file for the gate definitions. So we move back to this our NC launch folder. We check the ls. So in code folder, I put the files, required files. So we required technology.v file, then test bench file, and there are two from RC and the design vision. These are the gate netlist. We just check for the completion. First, the FSM from the synopsis. This is the gate netlist from the synopsis design vision. This is from the RC. Okay. Quick look of that test bench. Okay. Here is the instance of the synopsis file. Okay, you just remember that. So again we can check the library file. It is a very large file with all the cells listed here and the corresponding timing constraints. So you can refer at your own in later time. To simulate on this NC launch, we need to create one TCL file. In TCL files, we need to have 3 commands for the compilation, NC-log, and 3 for elaboration. So we are taking the get netlist, then test bench, and then library file. So similarly, we are going for the elaboration, and at the simulation we provide the top level module name. To have that, we just source it, source.nc-launch. So we are going for the get simulation. You can check the first schematic of it. Just click on this schematic. The get netlist from the design vision. Okay, it has almost 39 cells, so the schematic will be little bit large. Okay. This is okay. So we can have the simulation as well. I hit this waveform window. Let's run the simulation. Zoom fit. So the difference between the RTL simulation and the get netlist simulation is that it is with the propagation delay. It is with the delay that cells offered. Okay, if you look at this, there is a rising edge of the clock, but there is no at the moment change in the RGBY. Okay, it will take some time and it will reflect on the output. So that this timing constant is listed on that get netlist library. So that is why it is much closer to the real circuitry. Okay, that is why we need to simulate on the netlist, so that we can have the what information regarding the delay at the output of the pins. So we can also check the names. So in that file, we need to change this name with the colon as Netlist with the design with RC. Okay, so this TCL file is now for the RC netlist. Okay, so we also need to change in the test bench. So test bench. That we need at one RC. Then it's okay. Okay, now we resimulate using the same TCL file. We first check the schematic and then simulation. This is schematic for the design vision, RC compiler Netlist. So it has less cells as compared to design vision Netlist. We will check the simulation and select all, waveform window. Just hit the run button, zoom fit. So we got the same waveform, okay, but obviously there will be some delay in that with respect to clock, okay. So I hope this video is helpful for you, and please subscribe my channel and support me. Thank you.